Good afternoon, everybody. So I will present the SCISSOR project. This presentation is co-authored by Christoph Brandauer from Salzburg Research. So here is the introduction of the partners of the SCISSOR projects. So there are besides some research institutions, like University of Krakow, University UPMC from Paris, the CNIT, the Italian Research Consortium, Salzburg Research, and Q11. The industrial partners involved are first SIA, which is an electric company of a small island in Italy, and in this in the smart grid of this company, we have set up a testbed to monitor security in smart grids. Then we have a system, which is a system integrator, a big company, and two small companies. One is 6Q, and they deal with cloud computing. So they do cloud-in-a-box solutions that we have exploited in our project. And then we have RadioSense, which is another small company. They build sensors for environment monitoring. So we have built a project in which we want to collect and monitor several information for security reasons. So in a nutshell, the SCISSOR project is about building a highly scalable security monitoring framework. We integrate a wide range of heterogeneous sensors. So we have environment sensors like temperature sensor, humidity, light sensor. Then we have network monitoring. So we have a traditional device that listen to the network and try to detect bad behaviors. Then we have the smart camera monitoring. So we want to fuse, and we also have monitoring of SCADA system, the log of the SCADA system. So we want to fuse all this information and build a system that is able to collect this wide range of information. For this, we produced a dynamically adaptable and distributed data aggregation framework. So we studied the problem, how we can aggregate all this information in a scalable way. Then, once we are able to collect all this information and to report this to some point in which we can analyze it, we want to have advanced detection and correlation modules as extension to conventional SIEM, Security Information Event Managers. And as I said before, we exploit in order to deploy this infrastructure modern cloud computing concepts. So we built an architecture and we have implemented. The project is a 3 years project, and we are now in the final year. So we already have some running results of the project. The idea is to split our security framework into 4 layers. So we start from the lower layer where we have the actual monitoring of events, and we have, as I said before, several types of monitoring, from network monitoring to environment monitoring, smart cameras, and monitoring of SCADA logs and of logs of other IT system. Then we collect all this heterogeneous type of information. We can make a local, let's say, pre-processing of this information by having the concept of edge agents. So the edge agents are kind of close to the information, close to where the information is collected, and are able to process this information in order to make the system more scalable, in order not to flood the decision part with a huge amount of information. And then we have a messaging infrastructure. We use the Apache Kafka system, and this is an infrastructure in which we can feed all the information, and we have several consumer of this information. One is a traditional SIEM, which is extended, And then we have other advanced threat detection modules based on statistic analysis. So that was something similar to what was presented in the first presentation today in this session, that we are able to do statistical analysis on the data and try to detect their anomalies. So to provide some detail on what we have already built, we have this testbed in the island of Favignana. It's a small island in the west coast of Sicily. And it has a smart grid. And the interesting thing that it is, from the electrical power point of view, it is an isolated system. So the island is isolated. It has some power generator in a part of the island. And also it has some distributed generation with the solar panels. And so this is one of the cabin of the distribution infrastructure of this smart grid. And we have been able to deploy our monitoring framework within one of these, within exactly this cabin that is shown in the figure. So this is inside of the cabin. So it looks like any electrical distribution cabin, but there are a lot of equipment that we have put inside this cabin. So all these red squares, they are equipment that we have put inside. So there are some, for example, there is a cloud in a box device. Here we can run several virtual machines that controls all our monitoring framework. And then we have an RFID reader connected to antennas, and these antennas are reading a lot of sensors that have been placed in several parts of the cabin to detect light, humidity, temperature of devices, and so on. And we also have a network monitoring system in which we can monitor the information which is exchanged by the SCADA supervisor with the SCADA controlled element in this cabin. This is another look to the same system. So basically what I show you in the cabin is, oops, sorry. What I show you in the cabin is in this part of the picture. So there are the sensors for environment value. There are the smart cameras, and there are the network monitoring, which is controlling the SCADA traffic. And here is the cloud in a box device in which we put all our software that is needed to control all these devices. And the system is talking with the SCADA supervisor through some wireless connection. And we also have some monitoring on the SCADA supervisor itself. And we are sending all this information through our centralized cloud. This is a traditional cloud in a data center, which is in Paris. And here we are collecting all the information after that has been properly filtered by our ingestion modules. And also we have a second part of the test bed, which is as well in Paris, in which we replicated other SCADA equipment, but this is in a laboratory environment in which we can have more freedom to play with, for example, to run attacks or something like this. This is another representation of the system in which we show the some of the software tools that we have been using in order to set up the system. So most of this software technology is classical big data technologies. So technology that you use today in big data to collect information in a scalable framework. So for example, we have, oops, sorry, we have ingestion modules based on Logstash. We have processing modules based on Apache Flume. We are sending files of log using FileBit, and we have our messaging infrastructure, our messaging backbone based on Apache Kafka. And starting from this, we have the decision and analysis part, which is centralized. And here we apply we can apply different data analysis methodologies on the information that we collect. So we are using robust statistic methods to detect outliers, for example, in distribution of data. We are using Bayesian networks to model the normal behavior of the data, and again to detect the anomalous condition. And then we can have a correlation engine, more traditional one, based on correlation modules that can we develop in SIEM. We are using Prelude, which is an open source SIEM. So, situational awareness. So on top of all this data collection framework, we need to understand what's going on. So this is the problem of situation awareness, and we have to do it in a scalable manner, in near real time, correlating events coming from a very heterogeneous set of sensors. So I'll give you some example here. Here we are reporting the information collecting by different environment sensor. In particular, there are some tags that detects when a door is open or closed, based on the received signal strength from these passive tags, which is monitored by the antenna readers that I've shown you in the cabin. We have, for example, the possibility to detect with the same RFID system the presence of authorized badges carried by operators in the cabin. We have light sensors. We have a sensor when a given cabinet is open or closed. And there are some patterns that corresponds to unauthorized access. Basically, there are some doors that are opened, but in the same time, I'm detecting the badge, for example, of people that is has the authorization to enter in this room. So, but there are other similar patterns of the sensors which corresponds of unauthorized event, like unauthorized access and, for example, tampering of something in a cabinet, which can correspond to increase of a temperature sensor, for example. So the point is that if we carry on all this set of information that we read from the sensors in our centralized SIEM, we can overload the SIEM with too much information. So the point is that you cannot do we cannot do everything in a single centralized point, in a single correlation engine that needs to take care of all the events in your system. But we are trying to do in a scalable way by distributing the processing of events and aggregating them to achieve scalability. So we can have local correlation of events close to the place where the data is collected. And for doing this, you need software tools, software technology that I've shown, but also an hardware equipment like the one that we have shown with devices that can run like in a cloud, but close to the physical place where you collect the information. I think that this concludes presentation in time. So if there are questions for clarification,